In this video, we'll look at the angle between two lines. So it's actually the same formula for the angle between two vectors. You just use the direction vectors of the lines. So for line 1, the position vector is 3, 2, 1, and the direction vector is all the coefficients of t. So that's -4, 1, and 2. And yeah, the 3, 2, 1 just came from the constants out the front. Similarly, with line 2, we can deal with that. So the position vector is 1, 0, 3, and the direction vector is the coefficients of, in this case, s. So -1, 5, and 0. So the position vectors, it turns out they don't matter at all. So we can basically not worry about those. It's only the direction vectors that the lines are actually pointing, which influences the angle. So cos of theta is b1 dot b2 over mod b1 mod b2 with a mod around the top as well. So cos of theta equals, now if we do b1 dot b2, that's going to be -4 times -1 plus 1 times 5 plus 2 times 0. So that is dotting these two vectors together, x's, y's, and z's, and then add them all up. The modulus of b1 is going to be -4 squared plus 1 squared plus 2 squared. And then the modulus of b2 is going to be -1 squared plus 5 squared plus 0 squared. Okay. The dot product itself there is going to be 4 plus 5, so that's 9. The square root here is going to be root 21. And then the square root over here is going to be root of 26. So that is a cos of theta. Technically, there's a mod around the 9, but since that came out as positive, we can just leave it like that. And then we work out what the angle is. So weirdly enough, even though we really love radians, vectors tend to do a lot in degrees. So inverse cos of, and then we'll put all that stuff. So 9, you get root 21, and then root 26. So just make sure you're in degrees for these questions. If you're not in degrees, you can get there through setup. So like shift, setup, and then go down to angle, change that to degrees. So 67.3. Theta roughly equals 67.3 degrees. And that is the angle between those two lines. Now you can actually graph these two lines in 3D. These are what are called skew lines. They don't actually intersect. So sort of, it looks like they would if you look from that view, but in 3D they sort of go past each other. But if you could sort of make an angle between the two lines, the angle is what we just worked out. So 67.3 degrees. I'll note that there's also like two possible angles between the lines, because if you imagine like you've got the acute angle and the obtuse angle, like the small one and the big one, but we take the smaller one in this case. Okay, now find the angle between these lines. So the first one is pretty straightforward. So b1 is just the direction vector for the first one, that is 1, 2, 4. For the second one, it's not so straightforward because we need to convert it back. So they've used lambda. Let's use just, I don't know, t or something. So x plus 1 over 3 should equal t. Therefore, x plus 1 is 3t. So x is -1 plus 3t. And you can probably see why I like having constants first and then your like t things, because it keeps it all nice and neat. Y was already t. And 2 take z over 2 is t. So 2 take z is 2t. So therefore 2 equals z plus 2t, moving the z across to the right. So z is 2 take 2t. So the direction vector here, we're just going to pull off the x bit, the y bit, and the z bit. So b2 in this case is going to be at 3, 1, minus 2. That's the direction vector. And now all we need to do is apply that formula. So cos of theta is going to be b1 dot b2 mod it over the mods of the individual bits. Now the dot product, it's going to be 1 times 3, 2 times 1, and 4 times 2. So that's going to be 5 take 8. No. Mod B1 and mod B2. So mod B1 is going to be root of 21. And mod of B2 is going to be root of 9, 10, 14. Cool. Yeah, that gives us -3 on the top and root 21, root 14 on the bottom. Now, when you see bars around a number itself, that means you just flick it back to positive. So that's cos of theta. There we go. So theta has got to be inverse cos of all that. And then we can just work out what that is on a calculator. Okay, so we'll pop that in. There we go, 79.9. So again, that's the angle between those two lines.